Hey guys, this is your second video for waves called Properties of Waves. The first video was going to include this too, but you're welcome. I didn't include it. So, challenge kids, you need to label your notebook Properties of Waves and put the date on there. Regular science, you need to put the title Properties of Waves and the date on there. And the regular science kids, you need to grab a note guide. The note guide says Properties of Waves notes on top. Okay, and this will help you organize your notes a little bit. So, we talked about waves the other day, and then now we're going to get to some nitty-gritty details that I told you we'll talk about later. It's now later. Alright, so here we go. Ah, man. Last year we made the kids learn about 4 properties of waves. Bam. Bam. But now, this year, we changed it. And now there's only 3 properties of waves. So, there's 3 properties of waves that we expect you to know. 3. And the 3 properties of waves are amplitude, wavelength, and frequency. These 2 we actually talked about for 5 seconds in the other video. Since it was 15 minutes long, that's all we talked about it. And then we have not mentioned frequency before. Alright, so let's talk about amplitude first. So, regular science, this is the first word in the chart. You're going to write a definition and a picture. Okay, so an amplitude, the official scientific definition, is the maximum distance the particles of the medium move from the resting position. That's a long definition. I'll say it again. The maximum distance the particles of the wave move from their resting position. Of course, I'll put a picture up here for you. If you need to pause the video to get the definition down, feel free to do that. Okay, so look at these 3 waves. They're about the same width, like this much, but their height is different. Can you notice that? So the wave on top has a really tall wave. Remember we call these crests up top because they look like teeth, and these are troughs because they look like what the animals eat out of. So the crest is really tall, really low trough. Really tall crest, really low trough. The one in the medium, in the middle, has a medium crest and a medium trough. Look at this one on the bottom. It's a really teeny tiny crest, teeny tiny trough. Those are indeed amplitudes. The amplitude goes from the tippity top of the crest all the way to the resting position. Hey guys, you haven't met the resting position yet. This line in the middle, that's called the resting position. So remember my son's snake? He goes up and down. If I don't shake him, that's a straight line. That's the resting position. As soon as I start giving him energy, there's crests and troughs. So I usually draw this as a dotted line. This graphic I stole from the interweb as a solid line. It's no big deal. So that's the resting position. The amplitude is the crest up to the resting position. Technically, that should be the same length as the resting position to the trough. So if I took a ruler and literally measured that, it should be the same length. So the amplitude here is a little shorter. Here to here. It's a little shorter than the wave on top. And this amplitude, look at that, it's teeny tiny. So if I look at those yellow lines and I took a ruler and measured them, I would know the amplitude of these, and I would measure them in centimeters because I'm in science class. Okay, the next definition is wavelength. Wavelength is the distance between 2 corresponding parts in a wave. Corresponding means similar or same, or like, I guess similar is the best way to say it. So let's look at a picture. Hey, it looks very similar. I took away the resting position, and if I want to find the wavelength, I'm going to find 2 parts of the wave that are the same. So I'm going to look at the very top of a crest to the very top of the next crest, and I would draw a line to connect them as straight as I can go. That's not a great line. And then there you go, that's much better. I would measure that line, the second one I drew, and that's the wavelength. So again, tippity top of a crest to the tippity top of a crest, connect them with a straight line, measure that with a ruler, and you'll get how many centimeters that wavelength is. And then here's an even smaller wavelength, tippity top to tippity top. I could also do trough to trough. And that would be an acceptable way to find the wavelength also. Ah, dang it. Oh, I could use highlighter. So the very bottom of the trough to the very bottom. The very bottom of the trough to the very bottom. Please don't shortchange it. And what I mean, I'm going to get another color. Red means bad. Don't be like, oh, there we go. No. Go from the very bottom to the very bottom. Look at this new line. It's slightly longer than that line. So to ensure you don't mess it up, tippity top to tippity top, the very bottom to very bottom. And then again, you'll take a ruler and literally measure those. Okay. So that the picture could have gone in the picture area. And now we have one more definition left. Frequency. What's the frequency, Kenneth? It's an old song. Okay. So frequency. The number of waves that pass a given point in a certain amount of time. So, oh, sorry. There's my phone. This makes me think of if I was standing, I don't know, if I was standing near a highway. Don't know why I'm standing near a highway, but I am. So I'm standing off 141 by Central Middle, and I want to count how many cars go by. It doesn't matter how fast they're going. That has nothing to do with it. I will just stand at the light at 141 and count all the cars that go by. So at 1 in the morning, the frequency is going to be very low. There's nobody out in 1 in the morning, right? So I'm going to maybe get like 5 cars that go by in an hour from 1 to 2 in the morning. But if I do the same thing at like 7 in the morning, I'm going to get hundreds of cars that go by our school at 7 in the morning. The frequency will increase. So if I counted every single car that passed our school at 7 in the morning, I'm going to get a high frequency. If I count them at 1 in the morning, I'm going to get a low frequency. So frequent, again, means how often you do it. Do you frequently go to the bathroom? That means you go pretty often. So here's some examples of a wave with a low frequency. Look how this is not happening very often. I would call that seldom happening. And then you get a medium frequency. And then you got a high frequency wave where they're happening pretty often. So that's what frequency means. Again, you don't know how fast they're going. We just know they're happening pretty often. So let's practice. Draw a wave similar to this in your notebook. Wave 1, A, blah, 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 blah. Wave B, blah, 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 blah. I want you to label the wavelength and label the wave with a higher frequency. Maybe put a star by it. Pause the video. Draw the wavelength and just put a star by the wave with a higher frequency. And I'll do the same. I want purple now. Okay, welcome back. So, here's the wavelength of A, crest to crest. Here's the wavelength of B, crest to crest. So I drew a longer wavelength with B, but the one with the higher frequency is indeed A. There's lots of crest here. 1, 2, 3, 4. In this wave, only 1, 2. Alright, let's practice again. Let's pretend this is 12 meters long. How many waves do you see? Hint. A wave includes a crest, and a wave includes a trough. You ready for the answer? Here's one wave. Ooh, there's a crest. And here's a complete trough. So that's one wave in this little picture. Let me change colors so you can see the next wave. Let's go with yellow. Okay, here's another crest. Oops, you can't see it. Another crest and another trough. So that's 2. How many guessed 2? Well, there's more. Let's go with, ooh, I like that blue. That's pretty. Go with the light blue. Here's another crest. Here's another trough. How many people said 3? There's 3 waves in this picture. Remember, a wave has to have a crest, has to have a trough. Bada bing. A crest and a trough. So 1 crest, 1 trough, 1 wave. Yellow crest, yellow trough, 2 wave. Blue crest, blue trough, 3 waves. Yay. See? 3. Okay, kids. If you have any questions regarding The properties of waves, you need to find a teacher and ask. We do expect you to know the difference between amplitude, wavelength, and frequency. For the regular science, you have questions at the bottom of your note guide that I expect you to answer. The answer key is in the binder. Remember, you only use that to check your answers. Okay, hope you guys are having a good day. Talk to you later, Skater.